morning, we will explain the new practical method for STATCOM placement and seizing in power system that the authors have proposed. For this purpose, we will use this small power system. This small power system represents the Bolivian power system in the south part. The configuration of the system in this small system is like this. First, we have the generation in this area. The generation is combined cycles machines, and the demand is in this other area, Potosí and Sucre. The power supply is by two lines. One line is in 203 kilovolts line, this line, and the other line is in 150 kilovolts. The problem of this system is in contingency of the lines. The one critical contingency of the line is Sucre. In the contingency scenario, the power flow of this line goes by the other one in the 150 kilovolts line. This power transfer is by a high impedance because of the transformer and the line, and produce a voltage reduction in the substation in this area. The voltage reduction and the high impedance of the components results in instability problems of the units of Termoeléctrica del Sur. The stability problems is by a loss of synchronous of the units. Here we can see the result of the simulation, and the loss of synchronous is produced in 1 second more or less. This problem will help to show how the new proposed methodology determine the lowest one capacity of the STATCOM and the best location of the STATCOM in this area. For this reason, the methodology in the first stage computes the sensitivity analysis and the participation factor in each substations and determine the highest one. In that substations with high sensitivity analysis, we can install the STATCOM. But the question is, what's the capacity of the STATCOM? And that question is solved with this equation. The equation is computed with short-circuit power of each STATCOM substation and the delta voltage or difference of the voltage between normal condition and post-fault conditions. To show how the methodology determined the lowest was substation, the lowest was STATCOM capacity, and the best substation to install this STATCOM, we will explain the decision matrix. You can see here the decision matrix. The decision matrix have two components: the substations in each substation that the STATCOM installed, and the indicators, which indicators, the result of the indicators in each substations, how is represented the stability conditions. The indicators in each substation in this case, in this analysis case, has a good sensitivity in these three substations. The computed of the capacity of the STATCOM results in this way: 104 MVAs in Sucre, 230 kilovolts, and 73 MVAs in Punta 230 kilovolts. And in the Potosí 150 kilovolts, 110 of capacity of the STATCOM. With this capacity, the STATCOM of this capacity installed in these substations, the stability analysis results in this way. We have poor conditions in Sucre and the good conditions in Potosí and Puno. This decision matrix shows which station has the lowest capacity of the STATCOM that solves the stability problems of the tested system. In this way, we can see that the Punutuma 240 kilovolts with 73 MVAs of STATCOM capacity solves the stability problems, and this is the best conditions to installation of the STATCOM in this power system. Thank you.